Okay, so the topic here is user-defined data types, which is the chapter number 3, first chapter of paper number 3, sorry. And before we start this topic, we would do a little recap of what we actually learned previously about data types. So when I say data type, so what comes into your mind? See, every program needs to handle some sort of data. Every program has to input and output certain pieces of information, and every piece of information is different in its nature. For example, a user may need to handle integers, or a user may need to handle real values, or also a user may need to handle a collection of characters. So you already know that each kind of data has to be placed in its own variable, in its own container. If I want to enter a name, for example, shellcode, and I want to save it in an integer variable, so it is not possible because the data type will not match. So the data type is actually very important to understand and learn. And these data types which I'm actually recapping right now are those which are built in, these are the current data types, built-in data types, which are available in your programming language. You are very much familiar with them. Those data types may be integers and booleans and strings and decimal, any real data types. So now what actually data type tells us? A data type tells us that how much memory in the RAM is going to be given to that specific type of variable. How that variable will be stored in the memory. And each variable is given its own length in the memory. For example, if you look at this table, which is in front of you right now on your screen, so according to VB.NET, each built-in data type is given a specific length. For example, your integer is 4 bytes. Your real, if you choose single for that, it would be 4 bytes, and double for that, it would be 8 bytes. Your character will occupy 2 bytes. A string would give 2 bytes to each character, and the length of string will keep increasing as the size of the string increases. If you are entering a 3-character name, it will consume 6 bytes. If you are entering a 5-character name, it would consume 10 bytes. And a Boolean might consume 2 bytes. So this actually tells us which data type is using what number of bytes in your memory. This brings me to my current topic, which is the user-defined data types. Now, using these basic data types, which were provided to us by the developers of programming language, like integer, like integer or string or Boolean, these are the basic built-in data types. We can make our own data types. We as developer might need the data types to suit the need of our program. And maybe those data types were not provided by the programmer to us, by the developers of the language to us. Now, in this context, the word programmer can be a little bit confusing, because if I'm writing a program using the programming language, I'm also a programmer, and those people that develop the Visual Basic.NET, they might be also called the programmer. So don't let yourself confused by the word, because I'm right now talking about the users of the programming language, the people, us, who are using the programming language to develop their own programs. So a user-defined data types can be made by the use of built-in data types. There would be 2 types which I'm going to discuss These are composite and non-composite data types. It would be very suitable for us if you keep track of this through your book as well. Right now, we are at books page number 247. If you want to refer to some information, so you can always go back and check these things from the book. Maybe later on after the lecture, you can do it and read for your own knowledge. So a user-defined data type is composite and non-composite data type in the context of our syllabus. Okay. The voice lagging will settle in a moment. Hopefully. Yeah, is it better now? What about you, Umar? Okay. So as I was telling you that we are going to start discussing composite and non-composite data type. When I talk about non-composite user-defined data type, so always remember when I talk about the user-defined data type and non-composite user-defined data type, always remember that this data type has a definition which does not involve a reference to another type. Means it is something totally new that you are making. It has no relation with anything else. It's another data type. It's a new data type that you are creating for the sake of your own program. Meaning this data type will be a new thing. It will not be depending on any previous data types. For example, if I compare this with the built-in data types that we have, so I would say that a Boolean variable only requires an identifier like the name of the variable, and we can easily define that. Dim found as Boolean, or dim name as string, or dim number as integer. So all we need is an identifier. All we need is an identifier to declare a built-in data type. But a user-defined data type first has to have the data type declared. When you are trying to make a user-defined data type, when you're trying to make a user-defined data type, the first the data type has to be declared, and then the variable in that data type can be declared. Okay. So as I told you that a user-defined data type has to be clearly defined, explicitly defined before a variable can be created in that data type. Now let's explore what do we mean by that. Now first data type that we are going to study is enumerated data type. Now this is where I require a lot of your concentration, because the skills are going to start from this part. The first data type we are going to discuss is enumerated data type. Whenever we are discussing about enumerated data type, to remember that it is the list of all possible values. For example, you create a variable name. Now the variable name can have any value. It can be anyone's name. It can be Umar or Abdullah or Husnain or Hamza or whatever. Think about a situation where I have selected a list of 5 names, and only one of those 5 names can be picked up as the value. I would repeat that. Think of a situation where the list of possible values is there, and the values of variable can only be picked up from that list. That would be your enumerated data type. First, we have to define a list of possible values, and then that list of possible values will be used as a data type. After declaring the data type, we can declare variables and we can assign values to those variables. Now let's go through an example pseudocode, and then let's go through a program to understand this concept. The pseudocode example is actually, we would always start the type declaration by the keyword type. Okay. When we need to start defining a custom, a user defined data type, so we would always define it by the word type. Then what the name should be of that data type? This data type that I picked up from our syllabus is T directions. This T direction is going to become the name of my data type, just like an integer is the name of a data type, just like string is the name of data type. So this T direction is going to become the name of new data type. And afterwards, you can see there is a list of all possible values. Now, every variable which I create in this data type can only have the value from this list. Let me repeat that again. An enumerated data type is actually a list of all possible values, and from that possible values, you can assign the values to the variables. Now, in this example, we have declared a data type, T directions, and we have given it the possible values. And from these possible values, we can assign it any value to any variable which is created using this data type. Another data type we are defining, which is called T days. Be very focused and alert with me. Another data type which we are defining is T days, and T days has a list of all possible days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So every variable of day that I create using T day data type can only have the value from this list. This is the enumerated data type. If you are having any question, so I would recommend that you start posting those questions in chat. I would answer them as soon as this session of lecture is finished. Now, I hope everyone is clear up till now. Enumerated data type is a list of all possible values. Moving on, let's see the next part where we have declared variable. Now you know that this statement, that declare keyword, is used to declare the variable in pseudocode. This variable direction 1 is created as T direction. This variable day is declared as T day. First we define the data type, and then we are defining variables in those data types. And then we can give the values to those variables, but those values must belong to the list that we already created. I'm sure everyone is getting a good idea up till now that what is the meaning of enumerated data type, defining a list of possible values and then declaring the variables and then assigning the values to the variables from that list. So let's put it to the use of programming. Let's now open a program in which we can see the enumerated data type in action practically. Okay, I hope my screen is visible to all of you. Now, first thing is first. This enum is the keyword to declare enumerated data type. Everything that you have learned in AS, there is one big difference in this part of the syllabus, that everything you learned in AS, it was already somehow have been introduced in the O levels. Whatever you're going to learn right now in A2, mostly it is going to be new for you. So first of all, let's see that how we declare the user-defined data type. First, I want you to notice that I have declared the user-defined data type not in my submain, but in my module 1. This is the first point I want you to notice, that a user-defined data type is declared here in the module. I cannot declare it in my submain. If somehow I try to put that in my submain, for example, see what I have done. As soon as I did this, there are errors everywhere. It is not recognizing submain, it is not recognizing the enum. So the first point is that the user-defined data type must be declared globally, so they remain valid. So they remain valid in all the subroutines and in all the functions that we write in that program. So this is your enum directions, and in the directions I have made a list. This list is having all the directions that I think my program is going to use. Now what I can do here is, I can declare a variable direction1 as direction. And as you can see, I have given it a value. This part is actually clear to you. What I have done is I have used a simple dim statement, given it an identifier, and used the data type that I just made. Now, if I want to assign a value to this, just like this, remember we used to assign default value like this to the built-in data types. Now, what if we want to assign values to our user-defined data types? In the case of enumerated data type, the value assignment process works like this. You just pick the data type, place a dot, and the dot, a list would pop up that would show you that what are your possible choices, what are your possible options. The list of data types, the list of data items that we made is there, and I can pick anything. Yeah, I have seen your question, Abdullah. I would definitely get to that question right after I finish explaining this. Thank you for your feedback. So now I'm going to run this code and try to show you how this code outputs. Okay, it is giving me a 2. Now what's that about? Why is there a 2 here? Clearly it should be east. I have given it east. There is one more important point. That point is that in the enumerated data type, the list that you are making is ordered list. So in an ordered list, there are default numbers assigned to these elements. Just like the numbers are assigned to the array elements 0, 1, 2, 3, 4. So in the eyes of our .NET framework, our program, it's actually north is 0, south is 1, and east is 2, and west is 3. whatever order you pick in the enumerated data type, it would be kept like that. So pointers would be assigned 0, 1, 2, 3 to these elements, and when I'm trying to access the elements, I'm actually getting to their serial number in my list. I'm getting to their order number in my list. If I want to change this, I can always use the option toString. Now you can see that East has been printed there. I hope this point was clear to everybody. That in the enumerated data type, the items are actually numbered, they are ordered, and we can use this to our advantage. I will show you how. But let's get to the presentation for now, and then we would switch back to the program. The values defined in the enumerated data type or ordinal means that they have an implied order of values. An order is implied when I am making my list. For example, on the basis of that, I can even write my comparison statements. This is actually an example of a comparison statement. I have declared a variable weekend as Boolean, and I have declared a variable day using t days, which I created in the previous slide, remember? And I'm saying that weekend is equal to true if the day is greater than Friday. That means in my list, if we just quickly go back to the list, in my list, these are going to have, okay. Yeah. So I was talking about that there is an implied order in the enumerated data type. So if I'm taking this t days data type as an example, there would be an order from Monday to Sunday. So if the value of day was greater than Friday, so the variable of weekend would be set to true because it would be Saturday or Sunday. So keeping this thing in mind, that it's an ordered list and we can use the order to our advantage, let us switch back to our program. And let's try to do something else with our data type. Yeah. Now see this part of the program. Let's comment out this portion and let's look at this part right there. Okay. I have again created another variable direction1 as direction, and now I'm going to try to get the input from the user. I'm going to try and get the input from the user, means the user is going to tell me which direction they want to go, and then I would just print it. Now let's see. I can enter 1 and 1 would take me to south, because in ordered list I can use the order number to access my elements of the list. And I can also try to do this. Now watch very carefully. I'm trying to input north here, and I have already declared north in my enum data type. But when I do this, I am actually facing an error, which is telling me that conversion from string north to type integer is not valid. Because to access this enum, we are using integer. Here it is 0, 1, 2, and 3. I cannot use the strings in my enum data type. Let me show you this part again. If I try to enter 3, it would give me west because I'm converting it into the string. So it would go up there, see that 3 is referencing which element of the enum. When I point my cursor to that west, you can see that west is equal to 3 is also popping up. So I can access the elements of my enum data type based on their pointers, based on their serial numbers or their order number, but I cannot do this. I cannot access them based on a string because the data type is only going to accept the integer. So when I input string, it simply gave me an error. One last thing that I want to show you, that I can even go and change that order. 0, 1, 2, 3 was by default assigned. 0, 1, 2, 3 was assigned by default, but I can do it like this as well. Sorry, equality, and maybe this, and this, and this. So I have changed the numbers of my list. So now when I enter 5 or maybe 3, let's enter 3. So I would just simply get 3 back because 3 is stored here and 3 is being printed. Now the 3 is not referencing to the west. Now to get to west, I have to enter 8. Now I have to enter 8 here, and now 8 will point to the west. So you can change that order as the programmer. You can always change the order according to your own wishes. So this was about all that I wanted to tell you about the enum data type. Pay very close attention on how to declare it. And this part is not necessary. This was just to show you that you can change the serial number according to your own wishes as well. But the default is already implied. You don't need to worry about it. And when you are accessing it again, so you can make it to string. And then it would convert it back to the name of the element that you have chosen. One more thing that I want to talk about is pointer data type. Now, a pointer data type is something which is referencing a memory location. For example, I declare a variable. I said dim num1 as integer. Now, num1 is the name of my variable. Okay. But that variable is created somewhere in the memory. What is the physical address of that area in the memory? The physical area of that variable would be stored in the pointer of that variable. So you can imagine that every variable has its pointer variable as well. And that pointer variable holds the physical address of RAM where the variable is created. This is one pseudocode example of showing the pointer variables in your programs. You have already been dealing with the pointer variables. For example, you created arrays. In array, a pointer is used to point to the element of the array. So you have already been doing it. In your chapter, first chapter of paper 4, you will use again the pointer variables